Hi everyone, this will be our last section. We're wrapped up after this. So after I post this video, I'm also going to post your final. So it's important that everybody goes through, watches this video, and then checks the assignments tab because the video will be posted there, or your final will be there. So just do me a favor and make sure that's in by Sunday at the latest. I know it's kind of short notice for what I've been giving you in terms of your other tests, but I need everything in by Sunday. That's all the homework. That's all the tests. If it's not in by Sunday, I can't grade it, and if I can't grade it, I can't help you. That being said, as long as you submit everything, I don't want you to be worried about your grade. I don't want you to be worried about the content. I just need to see your best effort on paper submitted by this Sunday. And if you have any questions about that, please let me know. I'm willing to sit down and work with you, talk you through it, help you out with whatever work you need. So yeah, just please make sure that's submitted by the latest Sunday. Otherwise, it's going to be tough. Your grades are due pretty early this year. So, all right, let's get started with linear inequalities in two variables. So the first thing we're going to do is graph some linear inequalities in two variables. So the first thing we're going to consider is a graph of a linear inequality. Okay, so a line divides the plane into three parts: the part on the line, the part below the line, and the part above the line. And in the case of a linear inequality, you also have a half point. So essentially what we're going to do is we're going to graph like normal, and then we're going to find out what parts are also in your answer. So for example, we have x minus y is less than 6. So the first thing we want to do is just pretend that this is x minus y is equal to 6. Ignore the less than part. So then we need to graph this line. For me, I would probably subtract the x over, then divide by negative, but they wanted to do the intercept way, so we can do that. We'll set y equal to 0, then set x equal to 0, so it gives us our two intercepts of x is equal to 6 and y is equal to negative 6. So go ahead and graph those 2 points, and then we want to test something on either side. Sorry, they didn't even graph it. I just want to see if there's a picture. So essentially, we have our 2 points, and then we want to test a point that's not on the line. And then we just substitute these coordinates in. So we have the point, we have the line 6, 0, and 0, negative 6. It's the line that goes through those 2 points. So then we want to pick a point and test it. And the easiest one to do is 0, 0. So you plug in 0, 0, and you get that it's a true statement, right? That means that the solution is everything below, or everything above this line, right? So it all comes together on this page. So essentially we graphed those 2 points that we found, 6, 0, negative 6, or 0, negative 6, and then we tested the point 0, 0. And because the point 0, 0 works, we know that everything above this line also works. So this is what your graph is going to look like. It's got a dotted line, and then you shade everything above it. So let's try this one. In this case, we have y is greater than or equal to 0. So the first thing we want to graph is the line y equals 0, right? And remember, if it's a y equals statement, it's just a horizontal line. It says it equals 0, we put it on the 0 line. And now let's go back and see if we even need a test point. In this case, we have that y is greater than or equal to 0. Well, do we need to test that, or could we just read that? It says y is greater than or equal to 0, so is y going to be above this line or below it? Well, if it's greater than, it's going to be above it. And again, this one is a solid line because it's or equal to. Let's graph this one. We're going to replace our inequality symbol with an equal sign. Then we're going to graph it. And the way they chose to do it is by finding the y-intercept and the x-intercept. I'm fine with that, or I'm also fine just setting it as y equals mx plus b and solving from there. Any of those ways work. So the first thing we find is the x-intercept, so we plug in 0 for y, and we get the first point is 2, 0. Then we plug in 0 for x, solve it out, and we get that y equals negative 4. So now we have what x equals and what y equals, and now we want to plug in the origin. We're going to plug in 0, 0, and see if it comes out to be a true statement. So to plug in 0, 0, 4 times 0, 0, negative 2 times 0, 0. So we get 0 is greater than or equal to 8. Is that true? It's not. So because it is not true, we're going to graph our two intercepts, which are 2, 0, and 1, 2, 3, 4, 0, negative 4. And then, because 0, 0 is not a true statement, you graph the side that does not have 0, 0 on it. Let's try another one. We have y is greater than 1. So this is a dashed line because it's not or equal to. So it's a dashed line at 1. And then y is greater than 1. So we graph everything above 1. So let's look at some mathematical models. These are, again, going to be kind of like word problem. So just as two or more linear equations make up a system of linear equations, two or more linear inequalities make up a system of linear inequalities. This is exactly the same thing we did last time. So in this case, we have temperature and precipitation affect whether or not trees and forests can grow. At certain levels of precipitation and temperature, only grasslands and deserts will exist. And the figure shows the three regions that result from the various ranges of temperature and precipitation. So let's see. We have two equations here, right? And we have two parameters. We have the annual precipitation, the annual temperature. In this little sweet spot right in here, only grasslands can grow. Above it, we have forests, and below we have deserts. So for an annual average temperature that exceeds 35 degrees Fahrenheit, the inequalities 5t minus 7p is greater than 70, and 3t minus 35p is less than or equal to negative 140. Those show you where the grasslands can occur. We want to show that the coordinates of B satisfy both of these inequalities, right? Because B should satisfy both of them. So we're going to substitute it in each inequality. We get that 160 is greater than or equal to 70. That's true. And then we plug it into the second one, and we get another true statement. So now we find out that the point B does describe where grasslands occur. Now let's graph the system of linear inequalities. You're not going to have to worry about a word problem on this test, so if that part was kind of, don't worry about it. So let's look at the solution set of linear inequalities in two variables. So we're looking for the set of all ordered pairs that satisfy both equations. So in this case, the answer is going to be the place where it intersects. So let's graph these two systems here. We have x plus y is greater than 3 and x plus y is greater than negative 2. So let's replace them both with an equal sign and graph both of these lines. So to graph the first one, or actually to graph both of them, we found out that our first x-intercepts are x equals 3 and x equals negative 2. So your two x-intercepts are 3, 0 and negative 2, 0. Then we'll replace x with 0, get our y-intercept of 0, 3 and 0, negative 2, and now we have those 2 points. And since both of these are just strictly greater than symbols, they're both going to be dashed lines. And because the point 0, 0 makes the first one false, we shade the half plane not containing 0, 0, right? Look at this first one here. Because 0 plus 0 is greater than 3. Is that true? No, it's not. So the point 0, 0 does not satisfy this first line. So we graph everything above it. Now we look at the second one. And I'm sorry, I'm replacing this with a less than symbol right here. So let's plug in 0, 0 to the second one. We get 0 plus 0 is greater than negative 2. So because that one becomes true, you can see where the negatives line up, right? So they graph that second line. They use the intercepts that we talked about, the intercepts in negative 2, 0 and 0, negative 2. And then they plug in the origin, find out that it's a true statement, so we graph everything on that side. So your real answer is just the part that satisfies both of them. It's the part that they intersect on. In this case, it just so happens to be everything that satisfies the first equation. So let's look at another word problem involving these. An elevator can hold less than 2,000 pounds. If children weigh an average of 80 pounds and adults average 160, we want to see a system of inequalities that model when the elevator holding X children and Y adults is overloaded. So let's start by graphing the solution system in parts A. Well, actually, we have to start by building our equation, right? The first thing we're going to talk about is that the number of children will always be 0 or more, so we get our first inequality, right? The first inequality is X is greater than 0. Okay. And then we get a second one, right? We also want to talk about when y is greater than or equal to 0. We don't care when we have negative people, right? That doesn't make sense. So we're always going to have at least 0 people. So that gives you your first two equations. Now we want to look at our second equation. So we want to talk about when we have 80x, because that's the weight of a child, and we already said that x is children. And now we want to add that by 160y, because that's the average weight of adults. So then the last thing we want to talk about is when these two things are less than 2,000. This is actually, should be backwards, right? This should be facing the other way. But it gives you your three inequalities anyway. So the first thing we're going to do is graph these inequalities. Since the first two are already pretty much set up for us, x equals y and x equals 0, we just have to look for the intercepts for the last one. We get our y-intercept, or our x-intercept by setting y equal to 0. We send our x-intercept by setting, y-intercept by setting x equal to 0. Solve them both off to get that x equals 25 and y equals 12.5. That gives us our two intercepts. So the first line they graph is y is greater than or equal to 0, or just y equals 0. So now we take a test point and we just say, well, y is going to be greater than 0, so that's the only part we care about. Next thing we talk about is this x is greater than or equal to 0. So we graph that x right at this 0 line, and we graph everything to the right because we say it's greater than this line. So we've officially eliminated this section down here and this section on the top left because they don't satisfy both equations. So now the last thing we want to talk about is when we graph this last line, right? So the region that they have in common ends up being this portion up here, but actually it's supposed to be down here, right? Because if we reread the question, this is where the PowerPoint is on. I'm scrolling all the way back to the beginning. We want a system of inequalities when the elevator holding x children y is overloaded. Oh, actually, I'm wrong. We're talking about when this is greater than that capacity. So actually, you're safe down in here, but this equation right here, this region, tells you when you're actually overloaded. So I actually misread the question, so it's actually right. This tells us where the region is overloaded. It's everything above this line. All right, let's graph this system of equations. First thing we do is set them as equals, and we look and say, well, this one's going to be a dotted line, this one's going to be a solid line. So now we graph the first one by setting your, they start with a test point, but essentially you're going to have to graph that one too, and then you grab a test point for the second one, and once you graph them off, your equation is going to look like this, right? So they kind of cut out the graphing part because we've done graphing in multiple different sections and talked about it a lot today, but they found that the test point 0, 0 satisfies both of these equations, so you get the entire region above both of those lines is where it overlaps. And you're going to see the same type of thing for this one. So in this middle portion here, there's actually an extra step. We know that when we're talking about these type of equations, we have to separate them into two separate equations. So we do -2 is less than or equal to x, and x is less than 1. So now we have these three equations, graph them all, and we check their test points. And the test point that they use primarily is 0, 0. You can really use any point, you just have to pick it. 0, 0 is just usually the easiest one. So we find out that the test point works for all of these statements. It's true for all of them. So essentially, you're just going to graph the section that has 0, 0 in it. So after you graph those four lines, you just graph the portion that 0, 0 corresponds to, which is that middle part in there. Okay, so I know this section is a little different than the rest of section 4, so don't stress on it too hard. I really want you to focus on the first couple parts of section 4. And please email me, let me know if you have any questions, and get your final and get any other work you have in. I'll take anything throughout the semester. I just need it in. I'm trying to make sure everybody can get through this together, and I really appreciate you sticking with me through this. I know it wasn't the ideal situation completing a course like this, but really impressed that everybody stuck it through. So let me know if you have any questions, if there's anything I can do to help you.